what we're going to do today is we are going to transform or change an image. Okay? So we're going to start with this idea of plotting just 3 points, and then we're going to make a triangle. Then we're going to change that triangle by scaling it. Okay? Another name that your book uses for this is dilating it. Where have you heard the word dilate before? Yeah, Reese? Your pupils can dilate. How many of you have ever stood in front of a mirror and you flipped the light on and off and watched what your eyes do? Okay? If you've never done that, try it. It's the creepiest thing, one of the creepiest things you'll ever experience about yourself. When you flip the lights off, your eyes get huge. And I would recommend doing it so it's pitch black. And then you flip the lights on really fast and you watch what happens, and you will see that your eyes were huge, your pupils were huge, and then they shrink way down. And you'll actually watch your eyes do this automatically. You have no control over it. Okay? So you'll literally see your eyes go from big black masses to tiny little dots. Oh, and it does it. It goes, and it's like, what is happening? Okay? If it made that noise, that would be the creepiest thing ever. You just hear people going around all day like, and be like, okay? So, what we're going to do today is we're going to dilate figures, okay? We can make them smaller, we can make them larger, okay? That's what we're doing. Another name for this is scaling. We're going to do this through a special type of transformation. Transformations means we are going to be moving the points of an object to make it larger or smaller. To give you a simple version or just kind of a basis for this, I'm going to go ahead and flip over one page here. Okay, you can take notes below your coordinate plane or on a different sheet of paper. If you need multiple pages, that's fine. I'm going to draw a figure for you. Okay, this is going to be just a simple triangle, like so. And I'm going to scale it. Okay, so I'm going to go ahead. There's the triangle. I'm going to copy it first. And let me go ahead and move this one. Okay, I'm going to paste the new figure here. And I can scale this figure. Okay, so I can paste a new one, and you can't see it yet. Okay, I can have that one. Okay, this is the original here. What have I done to this one? I've shrunk it. I've made it smaller. Does it look the same? Yeah, when they look the same, we could say they're similar. Okay, all the angles are the same, so we would say that it indeed is similar. Now, I could also make this figure larger. Okay, and let me tap off it, and there it is. Okay, and now I have a figure that is larger than the original. Okay, so but it has all the same proportions. Okay, it has all the same proportions. So let me go ahead and I'm going to show you another way to think about this. I'm going to remove these arrows. Let's say that I take this small figure and I move it so that it is inside the other one, like, let me make sure they're overlapped just real carefully here. And you'll see this pop up on the screen here shortly, like so. Okay, zoom in on this. Okay, there it is. Now, let's say that the smaller one is 1/3 the size of the larger one. Okay, so we're going to say that the scale factor, which is the number by which we're changing the image, is equal to 1/3. Okay, that means that your new image is 1/3 your original. Okay, I'm going to say that the original triangle had a large side of length 9, had a hypotenuse of 12, and that this side was 6. Okay? Those numbers aren't necessarily accurate, but they're going to give you a picture of what we're talking about here. Could you tell me what the new lengths are on the smaller triangle if we've scaled it or we've shrunk it by 1/3? Kennedy? Yes, that's exactly what it would be. They'd be 2, okay? It'd be 2 here. It'd be 3 here, and it would be 4 here. Because I would take 6, I would divide it by 3, or multiply it by 1/3. I would take 9, multiply it by 1/3, and that becomes 3. Take 12, multiply it by 1/3, and it becomes 4. So the idea here is that I can take numbers and multiply them by the scale factor, and they can get larger or smaller. Just to show you the math, 6 times 1/3, okay, is going to equal 6 over 3. Wow, that is a messed up 3. There, new 3, which equals 2. Hence the reason there's a 2 there. I could take 9 and times it by 1/3, and that equals 9 over 3. And when you divide 9 or 3 into 9, you get 3, and that's why there's a 3 here. And last but not least, if you take 12 and you multiply it by 1/3, you get 12 over 3, which is 4. And that's why there's a 4 right there. Okay? So when we scale something, we can make it larger or smaller, but we try to keep the proportions, the sides and angles, to each other the same. Okay? So the angles usually stay the same, and the sides usually keep the same proportions. All right. So I wanted to give you a little bit of a background on this. Let's just practice this real quick. Let's saying, well, nonetheless, I'll give you a little background, I have only had 2 cups of coffee. I'm not at my game. I'm not up to par yet. Only 2. Let's draw a rectangle that is blue. Go ahead and draw a smaller rectangle like so. You don't need to draw this one in the coordinate plane yet. We're going to get to the coordinate plane in just a moment. This rectangle is going to have sides 3 on the shorter sides and 5 on the longer sides. And I'm going to give you a scale factor that's equal to 2. Now, if I'm going to scale this figure by 2, what do you think the lengths of the new rectangle are going to become? David? Okay, so you're saying the 3's are going to become 6's and the 5's are going to become 10's. Okay, so let's draw a new rectangle. Okay, that's probably approximately what I'm looking for. And yes, the sides would become 6's, David, and the other sides would become 10. Okay? Do we understand, for the most part, this scaling idea? I would hope so. I would hope so. Now, sometimes you're going to be given coordinates. And like in your homework, you have 2 problems that are going to deal with actually coordinates. And the question becomes, okay, we can look at an image and we can see the sides and we can see what those sides have, but we don't necessarily know then how to use this in a coordinate plane. So that's what we're going to look at next. I should mention one more thing here. And let me draw a triangle for you. They're going to use this terminology called center, okay? Center A or center B or center C in your homework tonight. And this terminology stems from the idea that you have different points on your triangle. So let's call that A, let's call that B, and let's call this C. Let's call this side 6. Let's call this side 7. Let's call this side, well, we could actually figure out what it would be in real life. Okay, let's actually make it accurate. 6 squared plus 7 squared equals 36 plus 49. Someone do that for me real quick. 85, thanks. Nice job. Preemptive. Very good, very good. So that side's going to be the square root of 85, or what would be the decimal for that? Someone want to? What is it, like 9.2? 9.1? Is it really 9.16? 9.21. We'll go 9.2. It's roughly. Oh no, Mr. Bornheimer. Oh. 9.2. I did. Thanks. It is roughly 9.2. Okay? Let's say that I want you to scale the image triangle ABC by half using center B. Okay, what they mean by that, ladies and gentlemen, is that you're going to scale it, but you're going to hold B in the same spot. So point A is going to move, and point C is going to move, but point B is going to stay in the same spot. So what we're going to do is I'm going to put a new point, B prime here, and it's going to be in the same spot. This is center B. And now that I'm scaling it by half, where do I move point A to? Yeah, David. Okay, half the length of 6, so I'm going to go 3 spaces this way. I'm going to put a point here, and I'm going to call the distance between what this is going to be called A prime. The distance here is going to be 3. Now, where do I move point C to? Where am I going to move point C? Reese. I'm going to move it 3.5 up the line here. I'm going to put a point right about here. Okay, I'm going to call this C prime. And we're going to name this distance here 3.5. And now I can go ahead and connect those like so. And I have my new triangle A prime, B prime, C prime, or triangle ABC prime. You can do one more thing. Does anyone want to take a gander at what the distance between A prime and C prime might be? Okay, so the hypotenuse of our littler triangle. What's the hypotenuse length of the littler triangle? It's not going to be, it's going to be close to 4.5 because that's half of 9. It's going to be 4 point what, Reese? Yeah, it's going to be approximately 4 points. That's a great gander, man. Don't be mocking me. Gander? Hey. Oh, man. All right. Ladies and gentlemen, let's make the following points. Let's make the following points. I want you to plot A at 3, 3, B at 5, 7, and C at 7, 4. Okay, plot those 3 points right now for me on your coordinate plane. We're not going to open a window because it's hard. It took a little while for this room to warm up this morning. So, okay, here's point A, 3, 3. Point B is going to be at 5, 7, so I'm going to go over 5. I'm going to go up 7. Okay, I'm going to put a point there. It's point B. Point C is 7, 4. So I'm going to start here at 7, and I'm going to go up 4 to there. put a point. That's point C. And then I'm going to connect them. Okay. What we're going to do is we're going to scale this by 2 factors. We're going to scale it by half, and we're going to scale it by 1.5. Okay, so we're going to be working with 2 different scale factors today. We're going to work with a scale factor of half and a scale factor of 1.5. So what I want you to do is I want you to go ahead and copy those points into a space where you can work with them for a little bit. Okay, so copy these points, A, B, and C, into a space you can work with them. Not necessarily a graph, but just someplace where we can manipulate them a little bit. I'll show you what I mean. If you want to watch it this first time, that's fine, and then take notes the second time, that might be even better. Oh yeah, I bet. All right, so let's go ahead and I'm going to be on my new sheet here, and I'm going to go ahead and paste the values. We're going to start with the scale factor of a half. All right, here's how this works. I'm going to zoom in a little bit so you can see it. We are going to say that A prime is going to be 1/2 of A. So you take every coordinate and you multiply it by a half. So I'm going to start by saying 3 times 1/2, comma, 3 times 1/2. That's going to be A prime. This actually works out to be 3/2 and 3/2. Right, and it might actually be a benefit to you to write it as a decimal, so let's do that as well. 1.5, 1.5. Okay. Now for B, what we're going to do is we're going to go ahead and put B prime. And B is 5/7. So we're going to do the same thing. We're going to take 5 and multiply it by 1/2, comma, take 7, multiply it by 1/2. Yeah, and if we want to convert those right into decimals, that might be best. So we're going to go B prime is equal to, what's half of a 5? 2.5, and half of 7 is 3.5. Okay. Now, shh, ladies and gentlemen, look up on the screen, please. I'm multiplying every point by a half because that's my scale factor. Every coordinate gets multiplied by a half. That's how you scale it. It's that simple. You just multiply every coordinate. I'll give you the coordinates. You just multiply each number by half and change them. So C prime, what was the coordinates for C prime? Okay, so you take 7 and you multiply it by what? 1/2. And you take 4 and you multiply it by 1/2. And it becomes C prime 3.5 and 2. All right. Once you've done that, you are basically done finding the points you need for that scale factor. And so you go back over to your original here. You copy those points in there. I'm going to change their color so that we can work with that. And now we plot them. So go ahead and do that on your coordinate plane right now. Plot 1.5, 1.5, 2.5, 3.5, 3.5, 2. So 1.5 would be A prime. 2.5, 3.5 would be B prime. And 3.5, 2 would be C prime. And then you connect the dots. Okay. Is that triangle that we just made, triangle ABC prime, similar to the larger original image? It is. The angles are the same. It has the same general shape. Okay, so they're similar. I want you right now at your tables with maybe the person next to you to try this, but instead of using a scale factor of half like we did here, okay, notice scale factor, I want you to try it with a scale factor of 1.5. Now this is not difficult, okay, so let's go. I'm going to go ahead and add an image here to get you started. Yep. And actually, Casey, would you read them off to me? The original. 3, 3. I know. You're going to use a scale factor. What's a way to write 1.5 as an improper fraction? Yep. 3/2. Go ahead and do that right now. Take maybe 5-6 minutes and find. What you're finding here is you're going to find A double prime, B double prime, and C double prime. And if you have time, you get done with it quickly, you can plot it. Okay? So you're just going to basically find the new points. Are they going to be larger than your original or smaller? They're going to be larger because your scale factor is greater than 1. Okay? It's actually going to be 150% larger. Mhm. All right. We have our new points. A double prime is 4.5, 4.5. So it's going to be a point right here. What is B double prime? Oh, wow, it's up there. Okay, so that's B double prime. And then C double prime. And then we're going to connect the dots. Okay, it's kind of like we have a Christmas tree, or as one person described it, the little skip thingy with the 3 triangles when you want to skip forward or skip backwards. Okay. So was the single prime an enlargement or a reduction? The single prime, ABC prime. Was it an enlargement or a reduction? It was a reduction. Was double prime an enlargement or a reduction? An enlargement. Do you guys feel like you have a basic understanding of what we're doing here? We're making objects larger or smaller? Okay.